For part A, we want to draw a graph of our function between 0 and 3 and see what it's doing. So I'm going to use the graphing calculator to help me out. So I input my function, I use x instead of t. Now I need to pick an appropriate window. Well, I know I'm going from 0 to 3 for the t value, so how about we just do -1 to 4 just to give a little bit of extra room. Also on the y-min I did a -1 because I don't care about negative y values or negative outputs because this function is measuring the height of the ball and I'm not worried about negative heights because the ground is going to be at 0. And I put in a y-max of 100. I think the maximum height of this ball is going to be 64 based on the function, and we're going to verify that here in a second. But that might be my cue to say, okay, I want something a little bit bigger than 64 for my y-max, and we go ahead and graph it, and there's our graph. So we'll draw our axes. Now this problem only asked us to do it from 0 up to 3. So right there's my graph. Now it asks us to label a few points. I'm just going to do a few of them and show you how we can calculate these easily. So they wanted this point, and this point. So let's see how we can get those real quick. Now, one way to get this first one, notice that t is equal to 0. So I'm going to calculate s of 0, which is 64 minus 16 times t minus 0 minus 1 squared. 0 minus 1 is a -1, squared is 1, so 64 minus 16, or 48. So labeling that point, that would be the point 0, 48. That says at 0 seconds, the ball is 48 feet high. Now, I'm going to show you how you can calculate a maximum with the graphing calculator. You can do second, calculate maximum. We hit enter, and now it's going to ask for a left bound, so I need to point to the left of the maximum, and a right bound, so I need to point to the right of the maximum. Now when it says guess, I hit enter, and there's my maximum. Now, the calculator doesn't give us the exact maximum. We're going to see later this semester how we can calculate it with using calculus. But our maximum is at the point 1, 64. So what is that saying? Well, at 1 second, the ball is 64 feet in the air. Lastly, we want to figure out where it hits the ground. Well, that's where the height is 0, so we can set our function 64 minus 16 times t minus 1 squared equal to 0 and solve. So we'll add 16 times t minus 1 squared to both sides, and that gives us 64 equals 16 times t minus 1 squared. Divide both sides by 16, because that cancels. Over here we get 4 equals t minus 1 squared. And now we'll square root both sides to get rid of the square here. So those will cancel. Remember, when we do square root, we have to account for the plus and minus. So over here I've got plus and minus 2 equals t minus 1. Adding the 1 over, I get t equals 1 plus or minus 2. So I'm going to get two t values. In fact, I'm going to get t equals 1 plus 2 is 3. 1 minus 2 is -1. Well, that makes sense because there was a piece of the graph over here that we didn't draw. So there is an x value over here, or an x-intercept, or a t-intercept at -1. But now we know the point here is 3, 0. So at 3 seconds, it hits the ground, or it has a height of 0. And we can label some other points by inputting t values and calculating the height, but I just wanted to look at those 3 values in particular.